Hello, Algebra 2 students. Today we're going to use the graphing calculator to finish up the 5.8 notes. So if we look at example number 1 and we go to part C, where it says approximate the local minimum and then approximate the local maximum, I will show you how to do that. So the first thing we're going to do is we're going to go to y equals and we're going to write that equation. So y sub 1 just means f of x, and the right side of your equal sign is where you're going to put your equation. So it's x plus 1 to the second power times, so scroll over and move your cursor key, x minus 1, oops, there we go, times x plus 3. And then we're going to hit graph. The graph is the very top button on the top row, far right. And there's your graph. So notice I already had you plot the X intercepts. So the X intercepts is where the graph touches the x-axis. How do you know if something is a double zero? It touches the x-axis, but it comes right back down. It doesn't cross. When it crosses the x-axis, then you only have one solution. So right there is a double zero. Now it doesn't show that's exactly -1, but it is because it doesn't go over the x-axis. And then over here is also, it went too far, but where it touches the x-axis is another 0, and then the third one is to the right of the origin. And so this is what the shape looks like. So what we're going to do is find the local minimum and local maximum. And in order to do that, what you do is you go to math, and actually, sorry, so you go to, get out of there, second trace, and that goes to calculate, and you want to calculate a maximum and a minimum. So let's do minimum first because that's what we're asked. So you go to number 3, hit enter, and how I got to that menu, remember, was second and the word trace up here, which is next to graph. And we want to do minimum first, and we'll do maximum. So minimum, so what you do is your minimum point is your lowest points on your graph. So the first minimum is right at the dip at that bottom. So you want to be to the left of that point. So that's left of that minimum, the dip. So you want to hit enter once you're satisfied with that little flashing cursor. And now you move a little to the right of that dip, and it'll draw 2 bars like that. And then it's going to calculate where that minimum is. So you hit enter one more time. So you enter 3 times. And so it says, do you want to guess that it's -1.96, comma, -2.87? And I'll just say yes. But here's the actual one. So the actual minimum is -2.4, comma, -4. So that's what you're going to put in part C as your first minimum. So -2.4, comma, -0.4. Now we're going to go back to second trace and do the other side and find its minimum, because there's 2 minimums. So move your cursor. Right there is about good, and hit enter when you're satisfied that's to the left, and then move your cursor again. Hit OK, and do the 2 lines, hit enter. And the other minimum is 0.4, comma, 0.41, comma, -4. Doesn't matter how many decimal places, I decided to use 2 there. And there's only one local maximum, and it's right here. It's right there, right around there. So you want to go to the left and right of it. So second trace, and you are going to find the maximum. So I like that as the left of the maximum. And then use your scroller and go to the right of it. Enter one more time, and there's your maximum. -0.999, so I just called it a -1. So -1, comma, that y value is so minuscule, anything raised to the -11th power, that's basically 0. So I called that -1, 0. And that was my local maximum for part D. And then you plot those remaining points, and that'll give you your graph. And that's how you use a graphing calculator to find a local max and minimum. And we'll do it again so you have practice if you have your own calculator. So turn to the back of your notes and look at example 2. So in example 2, we have 3 zeros. We already know that. So we are going to graph that equation. So y equals, I'm going to clear it, and I'm going to put negative x to the third. Negative is right to the left of the enter key. It's different than a minus, so you want to make sure you put negative. So negative x, caret key gives us my exponent to the third power. Scroll over, plus x. Here's a squared button if you don't want to use a caret key. Some people just use the caret key for any exponent, and that's fine. Plus 3x plus 3. And then hit graph again, and then you know what your graph looks like. So what you can't see is the arrows going up. So you have one arrow pointing up and the other arrow pointing down. And that makes sense because the leading coefficient was negative and the constant the leading coefficient is negative and it's odd degree. So that's going to point in opposite directions. Notice there's only 1 0, and it's right here where it touches the x-axis. And we're going to approximate that. So, to find the 0, again, you go to second and calculate. So go to second and hit the trace, and you want to calculate number 2, which is the 0. You want to find the 0. So go to the left of the 0. So it asks you a question, are you happy with the left bound? You should say yes. And then go below it and go right bound, hit enter, and then let it guess the 0. And it puts the cursor right at around the 0. So the 0 is 2.6, 0. And that is the second part of answer A. But you should be asking yourself, why do we only have 1 0 when the degree is 3? That's because the other two are imaginary. So you would write in part A that the zeros are x equals 2.6 and 2 imaginary, because there should be a total of 3 zeros. We can't find imaginary zeros on a calculator, but it makes sense because only one part of the graph touches the x-axis. So in part B, the answer is 2.6, 0. And in part C, we have one local maximum and one local minimum. So here's the local maximum, right about that there. And here's the local minimum, the lowest point, right about there. But we need to find out what they exactly are. So go to second, trace again, and let's start with the minimum since that's where we're at. And we want to go just to the left of it. It doesn't matter. You can even go right up here and hit enter if you're satisfied with it, as long as you know it's to the left of it. And then scroll over and go to the right of it. Hit enter, guess, and there's your minimum, negative 0.72, 1.73. And that is the answer to part C. We will find the maximum. So to find the maximum, go to second, trace, go to number 4, and let's go to the left of the maximum. So that is definitely to the left of it. And now let's scroll over to the right of the maximum. That's definitely to the right of the maximum. Bars are drawn, hit enter again. There's the maximum. So this is the answer to part D on number 2, 1.39, 6.42. And then all you would do is plot the points from parts B, C, and D, and then connect the dots with a curve, not straight line with a curve. And that's what your graph should look like. And what I'll do is at the end, I will post a picture of my completed notes so you can see what it looks like. And there you have it. So we'll do our last one. So problem number 3. Clearing that, our function is f of x equals x to the 4th. So x, caret key, to the 4th. In class, if we were in class, you would definitely be doing this. Minus x to the 3rd minus 4x squared plus 4. This is also going to be a W-shaped graph, and the reason why is the degree is 4, so that's even degree, and the leading coefficient in front is 1, so that's a leading coefficient is odd. So it will look like a W of some sort. Now it might not be a perfect W, but it's still a W. So the arrows are both pointing up. And what I wanted to mention actually was the leading coefficient is positive, and therefore the right end is going to point up. So that's how you know. There are 4 zeros, but you only see 2 of them, so the other 2 must be imaginary. Here's the 2 zeros you will see. Oops, well, it's right around there, right? And then here's the other one where it touches the x-axis. Well, it goes up. So let's go ahead and calculate the zeros first. Let's calculate the one that's right about there. So we want to go to the left of it. So go to second, trace, and we want to look at option 2. We're going to find our zeros because that's our part A. So go there, and our zero. So I don't know why I moved it. You want to go a little far up. So we're satisfied with the left bound. Scroll over. That's to the right of the 0, but don't go to the dip. And you enter again, and your 0 is 1, 0. So that's one of them. So for part A, x equals 1 is a 0. Now let's find the other one. So second, trace, and go to 0 again. And so here is to the left, enter, and scroll to the right, and that's far enough at least, enter. And it's going to find the 0 between those 2 small skinny vertical lines. And there's a 0, and it'll put the cursor right at the 0. So the other 0 is 2.39. X equals 2.39. And that y value is just 0. And well, it's going to be a 0 because that's why it's called a 0. And there's 2 imaginary. So write that down in part A. The zeros are x equals 1, x equals 2.39, and 2 imaginary. Now let's go to part B. Remember, the zeros mean the X intercepts. So the answer to B is just 1, 0 and 2.39, 0. We just need to do C and D with our graphing calculator. So go to second, trace again, and let's do the minimum, I guess. There's 2 minimums and 1 maximum. So one of the minimums is right there, but we need to calculate it. So now let's just go to do the first minimum. So let's go to the left of that, right there. I'm happy with that. Go to the right of it. I'm happy with that. Let it get the minimum, and it's right there. So one of the minimums is negative 1.09, 1.95. So this is part of the answer to C, and then we're going to find the other minimum. So go to second, trace, minimum, scroll over. Right there, I'm happy with it being to the left. Right there. See, I can even go there. It doesn't matter as long as it's to the left and right. And there's the vertical bars, and it's going to find the minimum. And the second minimum is 1.84, negative 4.31. So that is C. And I'll put the answers up here in a second. Finally, the last one is find the local maximum. So the local maximum is right there somewhere. It tells us 0.4, but you know, it definitely could look like 0.4, but let's just go ahead and calculate it. So second, trace, and we want to find the local maximum. So option 4, let's go to the left of it. That's good. Let's go to the right of it. That's good. Hit enter. It is 0.4. So remember, the 4.7 times 10 to the negative 7th basically means 0. So it's 0.4 is part D, local maximum. And then you would plot parts B, C, and D and connect the dots with a smooth curve. And I don't have the graphs on there, but this is what it would look like if I would show you. And these are the rest of the answers. So if you didn't get them, these are the answers. I just could not plot it really nicely with my line tool. I tried and it just didn't work very well because this is what happened. I tried to connect it with using my hands and I was just making a big mess of it and I just wasn't doing a good job. But you guys can do that and you can make better smooth curves. So that would be the first graph. And I didn't even bother doing the second or third. But what I want you to do is make sure you have the correct answers to your notes. And what I will do is I will go ahead and post a picture of my notes right underneath the notes in Canvas for 5.8. And those are my notes for today. So have a great day, Algebra 2 students.